Bismillahirrahmanirrahim. In the previous video, we have solved this P2 mathematics paper from May-June 2023 up to question number 4. In this session, we will solve question 5 onward. So this question number 5, the table shows the population and area of 3 countries in 2019. Sri Lanka, South Korea and Pakistan. The population is given as 2.18 10 to the power 7. For Korea is 5.17 in 10 to the power 7. For Pakistan 2.17 in 10 to the power 8. And the area is given as 6.56 10 to the power 4, 1 into 10 to the power 5 and 8.82 into 10 to the power 5. Write down the value of the smallest population. So this is the smallest population is this one, because this is 221.7 into 10 to the power 7. So the smallest population is this 2.17 into 10 to the power 7. So make the power same, 10 to the power 7. When this is 10 to the power 7, then this is 21.7. So this one is the smallest population. The second part is find the difference in the area between Sri Lanka and Pakistan. Sri Lanka area is this and the Pakistan's area is this, so makes it power or make it 10 to the power 5. So this is 0.656. So this is 8.82 and this is if we shift this point here, then this is 0.656 into 10 to the power 5. So this, so the power is same, so we can make a difference from 8.82 to 0.656, which is 164 into 10 to the power 6. So this is the area difference of area between Sri Lanka and Pakistan. This is part 2, and in 3, the population density of the country in the number of people per square kilometer. The number of population of density of Sri Lanka is 2.8. This is the population and this is the area. So this is population density is 2.18 into 10 to the power 7 people in this area. So this is population density for Sri Lanka is 3.23 into 10 to the power 2. Population density for Pakistan is 2.17 into 10 to the power 8 and divide by this, and this is the population density of Pakistan, and the population density of Sri Lanka is South Korea. This is South Korea. South Korea is 5.17 10 to the power 2. So the population density of Pakistan is small, while the population density of South Korea is quite high. This is find the value of the largest population density. So largest population density 5.170 into 10 to the power 0. So if we shift this point here, then this will gone, and 517 population per kilometer is the population of South Korea, which is very, very high. Pakistan, the population is 246 per kilometer square. In standard form, A is 8.6 into 10 to the power 9 and B is 1.5 into 10 to the power n minus 1. Give your answer in standard form, find in terms of n. So this is 8.6 into 10 to the power n and this is 1.5 into 10 to the power n minus 1. If we shift this point here, then this becomes 10 power n. So 8.6 minus 0.15 into 10 to the power n. Take this 10 to the power n as common, and 8.6 minus 0.15 is 8.45 into 10 to the power. So this is the standard form. If we multiply this A into B, so this is 2n, n plus n is 2n, and when multiply this with this one, it becomes 1.29 into 10 to the power 2n. So this is simple, this is very easy. And in question number 6, Sufia takes part in the trio challenge, and she walks, then cycles, and then swim. She walks, cycles and swim. First walk, then cycle and then swim. And this is the walk is 6.3 kilometer, cycling is 3000 meters and swim is 1800 meters. Write these distances in as a ratio in the simplest form. So this is 6.3 kilometer, this is 3000 meter, which is 3 kilometer, and this is 1800 meters, which is 1.8 meter. If we divide this by or we can write it as a 6.3 is 63 and 3 is 30 and this 18 is 1.8 is 18, but because this we have multiplied with a 10, so we have this whole numbers, and after that we divide this with 3, so it becomes 21, 10 and 6, and this is the simplest form we have obtained. So we have to obtain the ratio. So this ratio is walk, cycle and swim. Now part B, Sophia walks at an average speed of 1.5 meters per second. She completes the walk at 11:05. So find the time she starts walking. So this is 1.4 is the velocity or the speed, average speed, and this time is the total distance she walks is 6.3 kilometers. So 6.3 kilometers is 6.3 into 10 to the power 3 meters, and if we divide with the velocity, then time is obtained, and time is obtained as seconds, and we have to convert it into hours. So we divide with 3600 seconds in 1 hours. So this unity relation, and we have obtained is 1 hour 1.25 hours, which is 1 hour and 15 minutes. So this is 1 hour and 15 minutes is the end time. So we subtract this 1 hour and 15 minutes, and the start time is obtained as 9 hours and 50 minutes. So 9 hours, when we add this 9 hours 50 minutes with 1 hours 15 minutes, we will end up at 11:05. So this is very important question. And Sophia cycles the distance of 3000 meter correct to the nearest 10 meters. So the cycles of this distance is a time of 450 seconds correct to the nearest 10 seconds. Calculate the upper bound of her average cycling. So the distance she covered is 3000 plus, and this is 10 meters, so 10 divided by 2 is the upper bound, and we divide with the lower bound to get the upper bound of the average speed. So the time is 450 seconds and plus minus 10 upon 2, so we have this 3005, and here we have this 445, and with the ratio the average upper bound speed is 6.75 meters per second. This is question number 7. On Monday, the amount of money spent on a website by each customer was recorded. The table shows the result, and here we have the amount of money for $0 to $30 money, frequency is P, and $30 to $40 more than $30 and less than or equals to $40 is frequency is 18, and for $40 more than $40 to less than and equals to 50 is 24, 50 to 60 less than or equals to 60 is 19 frequency, and more than 60 and less than and equals to 90 is 24. So show the table results, and the histogram shows some of the results. This was drawn here. Some of the results are drawn, and we know that this is 30. So, and from here we read it 0.5. The frequency density is 0.5, and we know that frequency density means the class width. This if we divide the frequency by the class width, we get the frequency densities. So the frequency density divided by the class width. So if this is the frequency, and if we divide with the class width, which is 30, so P divided by 30 is equal to 0.5. So P divided by 30 is 0.5, so P is equal to 15. So this P is equal to 15 is obtained because of this histogram. And complete the histogram. This part 1 is obtained, and thus please see the diagram. And here we have this 18 divided by 10 is 1.8, and here we have defined this 30 to 40 boundary is 1.8. This is 1.8, and for 24, 50 to 50, 40 to 50 is 10 divided by 2.4 is the frequency density, so the value of 2.4 here. This is 2.4 for the range of 40 to 50, more than 40 and less than or equals to 50 is this region, and for 50 to 60 is 1.9. This is 1.9 from 50 to 60, and then 60 to 90 is 0.8. So 24 divided by 30, 24 divided by 30. So 24 divided by 30 is 0.8. So this is 0.8. Because the class width is quite large here, this is 30. Width of here, the class width is 10, 10, 10, and here 30, and here again 30. So here we have this 0.8. This is 0.8 from 60 to 90 for this band. This histogram completes here. Find the value of P is obtained, and histogram completes here. One of these customers is selected at random to receive a discount voucher. So one of the customer from this is selected to receive a discount voucher. Calculate the probability that this customer spent more than $50. More than $50. More than $50 is spent. This more than 50. So this probability that the customer lies in this region, we have to find the probability that the customer spent more than $50. So this is, so we have to find the probability that the customer spent more than $50. So money is spent more than $50 is equal to, this is 19 plus 24 divided by total probability, and total probability is 15, 18, this is 100. So this is already given, this total is 100. So we just add the total frequency, and the probability is 43 upon 100. The table shows the amount of money spent on a website by each customer on Tuesday. So this was the amount spent on Monday, and in the second graph the amount was spent on Tuesday. It was frequencies 22, here 16, 24, 19, and here we have 14. So calculate an estimate of the mean. So we have to find the mean value for this values tables, and here we have this mid frequency between 0 to 30 is 15. The mid frequency is mid class width is, mid value of this class is 35, this is 45, this is 55, and here we have 75. So this is the mid point of the class is this, and the frequency is 22, 16, 24, 8, 19, and 14. So this is all given here, and we multiply this midpoint with this frequency to get the product of this. So this is the product of these two, x and f is fx is here, and for this different class band, and the total is obtained as 4065. This product fx is 4065, and we divide with the total frequency. So the total frequency is 95. This total frequency is 95. So we divide this fx, summation of fx, with the total frequency is 95, and the value is obtained as 42.80. So the mean value, the mean amount that the person spent from this graph is estimated as $42.80. An error was made and one of the sales on Tuesday was not included in the table. Suppose that one of the sales was not included, then the customer spent $41. Tristan says that if the value had been included in the table, then the estimated mean would have been higher. Without calculation, explain why he is correct. Since $41 lie in the class 40 to 50. 40 to 50. So $41 is lie here in this band when the class midpoint is 45. Class midpoint is 45. 45 would include in the numerator, from while the frequency of 40 to 50 would increase from 24 to 25, because the one of the summation was omitted, so it will be 25, because this cost $41 lie here in this class, so this frequency will increase to 25, from 24 to 25, and this is that thus the mean would increase, because the mean value would increase. So this is correct. So this is just a understanding of this question. In the next session, we will discuss question number 8, 9 and 10, remaining questions.